Welcome to NASA Edge, an inside and outside look at all things NASA. Joining us today is Bob Moses, who's a senior aerospace technologist at NASA Langley Research Center. And Bob, thanks so much for joining us on the show.
Thank you, Blair, for the opportunity to tell you about some things on my mind on how we're going to go to the moon to stay and then on to Mars.
Speaking of the moon, how are you going to make things safe for the astronauts going? Because they're not just going for a single mission, we're going for a long time, a sustained presence on the moon.
Yeah, that's a great question, Blair. The plans for the Lunar Surface Innovation Initiative and what we want to do at Artemis is quite different than the Apollo program. To stay requires that the astronauts have other things that protect them from that harsh environment that we really didn't have to deal with during the Apollo program. Most specifically is the galactic cosmic ray radiation shielding. On the lunar surface, they will be exposed to the radiation, at least from space. And so covering their habitat or giving them somewhere between 3 to 5 meters of regolith over top of their habitat is going to be crucial so that they can stay there, especially if they're going to use the moon as their training ground before they go to Mars. They'll need to protect themselves so that they don't use up their lifetime dose. And then there's other things that we would do in terms of staying there. You might even have roads, and there are a lot of base designs, lunar base designs, that provide some vision for the things that we want to do there to stay.
Well, it's interesting you mentioned regolith on top of a structure because, fortunately, if you go to the moon, there's a lot of regolith there to use. How much did that play into the designs using those resources that you have there on the surface?
The nice thing about the lunar surface is that Mother Nature has, through thermal cycles and then just the impacts, have really pulverized the regolith, at least in the top 20 centimeters or something like that. It does vary where you are on the moon, but just some simple excavation seems to be enough to loosen it up, and then maybe just like a bulldozer attachment seems to be sufficient to start piling it up. So to bring that much material from Earth is just not possible. So it's great that the lunar regolith is already in a situation naturally to lend itself for this purpose.
And thinking of your title, Bob, you're a technologist. Now, a lot of different technologies will be brought to bear on this mission. What are some of the things that NASA is developing that maybe we haven't done before to help establish this presence on the moon?
One of the things that we're looking at right now is the fission reactors. We're going to need surface power. We know that we're going to end up with times where the sun is not going to give us what we need. Certainly going to the southern pole helps give us access to sun, but it's going to be so low on the horizon that there'll be times when it'll be a struggle to meet the demand. So that's where the fission power comes in. The other thing too is the landing system, the human landing system that was used for Apollo is quite different than what we're looking at now. And recently there was an announcement of the 3 winners to take their designs forward. And if you look at those, they're quite different than what Apollo used. And there's a lot more stuff they're going to land on the surface, the habitats and things that'll be there to stay. The other thing we're looking at, and this is where the construction really is coming into play, is how do you put down a landing pad so that when the lander comes in with all these things, first of all, it doesn't kick up a bunch of regolith into space and creates a debris field. And the other thing is it doesn't go and create debris that knocks out the things that were put there before. So it's a really good strategy that's in play right now to how you put all that together. How do you do the surface stuff before you land the biggest thing that you want to land there?
Yeah, that's a good point. We talked to Chris Wohl about dust mitigation, so I really appreciate the landing pad sort of helping your partners do this effectively. But one of the things I'm wondering is it still seems like there's an advantage if you can find a way to use that those resources on the moon to build those structures. Because if you can do that, then you're not having to transport this stuff with you, which would be really difficult.
So just for the landing pad, just use that as an example. There's a couple of approaches being explored further right now, and SpaceX is working with Kennedy Space Center to look at some of those as well. So we got industry involved to some extent, but there's what can you just take with you to bind with the regolith to make it stabilized enough to get that first suite of spacecraft down that doesn't require a lot of power. And then there's the one that approach where you say, wait a minute, I have all this power, sunlight. If I can collimate it and concentrate it, I know that I can heat up the regolith and start printing with like lava. And so we're looking at that approach as well.
How important is it to sort of develop these plans? Because it seems very inspirational. Sometimes you sit around and you think, how will we accomplish this big task? Even if these technologies don't come to fruition, they're very inspirational in making it seem possible. It seems like a big motivator to get everybody involved to get this massive task done.
You know, it's going to be our generation is going to do so much. And then it's the next generation that we want to inspire. And so your comment is exactly one of those levers to help us to motivate the next generation. And so I'm involved in some university challenges, and I certainly mentor early career as well as high school on up to PhD candidates. And enabling them to, or giving them an opportunity to bring their ideas forward is really invigorating. So it's really inspiring to see the technology, see the next generation coming in behind us who master it. And a lot of the technologies that they will master at that time, they're not even created yet. So it's a lot. It's a fun time to be alive.
Well, I tell you, you're exactly right, Bob. I mean, after DM2 and all this talk of Artemis and then going on to Mars, it is a very exciting time to be involved in space exploration. And we just thank you so much for coming on the show and sharing about this whole construction side of Artemis and going back to the moon and Mars. Thanks so much for your time.
It was my pleasure. Anytime. Thank you, Blair.
You're watching NASA Edge, an inside and outside look at all things NASA.